Hello, my name is Robin Wilson and I teach chemistry at Harrison Central High School in Gulfport, Mississippi. I have designed this tutorial to help students that are having difficulty solving 1, 2, and 3-step stoichiometry problems. Before we begin, let's review some stoichiometry basics. Stoichiometry is a method of record keeping used by chemists to calculate the quantity of one part of a chemical reaction based on the given of another part of the same chemical reaction. To perform stoichiometric calculations, we need 4 specific conversion factors. 3 of them are related to the mole. 1 mole of any compound equals the molar mass of that compound. 1 mole of any compound equals 6.02 times 10 to the 23rd molecules of that compound. This is also known as Avogadro's number. And 1 mole of a gas at standard temp and pressure equals 22.4 liters of gas. The last conversion factor we can use is the mole ratio, which is written using the coefficients in a balanced equation. This is the conversion factor used to change compounds when working a problem. So let's look at our first reaction. The balanced equation here represents the reaction that occurs in volcanic areas when oxygen gas reacts with hydrogen sulfide to produce sulfur dioxide and water. You may want to write down the equation because we will be using it for our other problems also. Following the balanced equation, you'll see our first problem. How many moles of oxygen are needed to completely react with 5.20 moles of hydrogen sulfide? Before we begin, we need to identify the given and the wanted values, so we ask ourselves, what are we given to start the problem, and what are we trying to find? 5.20 moles of hydrogen sulfide is the given value, and how many moles of oxygen is the wanted value. We will start by rewriting the problem to get rid of unnecessary parts of the question. 5.20 moles of hydrogen sulfide equals how many moles of oxygen. The given and the wanted units are both in moles. In this problem, we are converting from moles of one compound to moles of another. We will use the mole ratio to accomplish this. To start, we will write the given value over 1 like a fraction. We will add a bracket to hold each conversion factor so that the unit to be canceled is in the denominator and the wanted unit is in the numerator. We will use the coefficients from the equation for hydrogen sulfide and oxygen to fill in the bracket. 2 moles of H2S will go in the bottom of the bracket, and 3 moles of oxygen will go in the top of the bracket. Moles of hydrogen sulfide will cancel with moles of hydrogen sulfide in the given, and the only unit left is moles of oxygen, which is the wanted unit. When this happens, it's time to do the math. We multiply all numbers across the top and divide by all numbers in the bottom. 5.20 times 3 divided by 2 equals 7.8 on our calculators. When we check the significant figures of the given, we determine that it has 3, so our answer must have 3 as well. Our correctly rounded answer with units is 7.80 moles of oxygen. Let's try another problem using the same equation. This time we will perform the steps without as much direction. Our first task is to find the given and wanted values. 0.67 moles of hydrogen sulfide is the given, and how many liters of water is the wanted value. We rewrite to condense the problem. 0.67 moles hydrogen sulfide equals how many liters of water. We begin by writing the given over 1, and we analyze the unit to see what unit we have to cancel in the first bracket. Because the given is in moles and the wanted is a different compound, we will need the mole ratio first. Using the coefficients from the equation, we add the mole ratio to the bracket so that moles of hydrogen sulfide cancels. This leaves us with moles of water in the numerator. We will then convert this unit to liters using the gas conversion factor. Moles of water cancels, leaving liters of water, which is our wanted value, in the numerator. We do the math in our calculator and round to the significant figures of the given. 15.008 will round to 15 because the given has 2 significant figures. Our correctly rounded answer with units would be 15 liters of water. Let's look at one more using the same equation. What mass of sulfur dioxide is produced from the combustion of 100 grams of hydrogen sulfide? We identify the given and the wanted values. 100 grams of hydrogen sulfide equals how many grams of sulfur dioxide? We write the given over 1 and begin work. Because the given is in grams and our first conversion factor must include grams, we have to use the molar mass. The molar mass is equivalent to 1 mole of hydrogen sulfide. We'll place grams in the bottom with moles in the numerator. We will then use the mole ratio to change compounds. 2 moles of hydrogen sulfide will need to be placed in the denominator to cancel, and 2 moles of sulfur dioxide will be placed in the numerator. Remember, these 2's come from the balanced equation. Once we are to moles of sulfur dioxide, we can then convert moles to grams using the molar mass of the wanted compound. Mass of sulfur dioxide is what we want, so we're ready to do the math in our calculator. 100 times 2 times 64.07 divided by 34.09 divided by 2 gives us 187.94. We round to the significant figures of the given, which has 3, so our calculated answer will be rounded to 188. The final answer with units is 188 grams of sulfur dioxide. If you still need more help, I've included a link to the Khan Academy. Click here and select stoichiometry. Once there, select Example Problem 1. There are several problems here for you to view. That's all for me today. I hope I was able to assist you in learning how to solve stoichiometry problems. Thanks for listening.